Intermediate Algebra, Section 9.2, Equations with X and Y interchanged. It will be helpful in later work to be able to graph an equation in which the x and the y in the y equals a to the x, in other words, the exponential function, are interchanged. And let's look at an illustration of that here. They're asking us to graph the first equation here, y equals 3 to the x. This is an exponential function. We know that it will increase from left to right because of our a being greater than 1. And some test values to plug in to get a sense of this graph. We will put a 0, 3 to the 0 is 1. If we put a 1 in, 3 to the first is 3. If we put a 2 in, we would have 3 to the second, which is 9, so we can see it's increasing. If we put in a negative 1, 3 to the negative 1 is 1/3 when we take that negative exponent to the denominator. And let's do one more point. 3 to the negative 2 would be 1/3 to the second power, or 1/9. So as our x decreases, our y is going to get ever smaller and closer to 0. Plotting these points then, we have the point 0, 1. There's our y-intercept. We have the point 1, 3. We would have the point 2, 9, which is off the graph. It's just headed on up towards a positive value there. Negative 1, 1/3. We had the point negative 2, 1/9. So it's, as we said, it's getting closer and closer to our x-axis. So if we connect those points with a smooth curve, we have the classic exponential function graphed here. We have the y-intercept at 0, 1. From left to right, this exponential function is decreasing. Our range are all positive values. Our domain, as I previously mentioned, are all real numbers. In this other function that they're asking us to graph, if you notice, the x is alone on one side of the equation, and essentially what's happened is we have had an exchange between these two variables and their positions. So to find ordered pairs that are solutions, we will choose values for y and then compute the values of x for this second graph. So let me slide this over a notch. I'm still going to put x on the left, but we will put y and plug in the y first. So let's start with a 0. 3 to the 0 would be 1. If we let y equal 1, we would have 3 to the first power, which is 3. Y equal 2 would be 3 to the second power, 9. We can see as our y is increasing, so would our x. Let's try some negative values. 3 to the negative 1 is going to be 1/3. If we let y equal negative 2, we'd have 3 to the negative 2, and we saw that simplified is going to be 1/9. These points sound very similar to this, except in their placement. But let's plot them and connect them with a smooth curve. So we have the point 1, 0. We have the point 3, 1. We have the point 9, which is off the graph, and it's headed up here at 2. So we know that it's heading ever increasing as we go left to right, but let's see what it looks like for these other points. We have x of 1/3 and a negative 1. We have x of 1/9, so it's getting ever closer, closer to the y-axis, add a negative 2. So if I connect those with our smooth curve, here in this graph where the x and the y are switched from our exponential function, now our y-axis is acting as the asymptote here. So note that the curve looks just like the graph of y equals 3x, except that it's reflected about the y equal x line. And here's our y equal x line where we have this reflection. The point here is being reflected there. Likewise, this point is reflected there. And we have this 1-to-1 or inverse relationship between these two functions.